You're welcome once again to Moto Online, your online school. Today, we are going to have a scenario-based question in physics, paper code 535/1. And the scenario at hand for today is coming from a topic called electricity, and this how it goes. A man has the following electrical appliances in his house. 4 inside bulbs. Allow me to be summarizing the electric appliances that this man has. So has the following electric appliances in his house. 4 inside bulbs. 4 inside the bulbs. Each rated 240 volts, 60 watts. 60 watts that work for 8 hours. So the time for these bulbs, the time of working for these bulbs is equal to 8 hours a day. And that is one appliance. Another appliance, 2 security bulbs. So these are 2 security bulbs rated 240 V, 100 watts each that work for 14 hours. So the time equals to 14 hours per day. 1 television set. So we have a TV, a television set, a TV set. For it, it is rated 240 V, 120 watts that work for 10 hours. So the time equals to 10 hours. And the speaker. This man also has a speaker. So this speaker, the speaker is rated 240 V, 300 watts. For this, it works for 20 hours a day. Time equals to 20 hours a day. This man also has a fridge. There is a fridge which is rated 240 V and 600 watts. This fridge, for it, the rating for this fridge was 200 watts. 200 watts, and it works for 4 hours a day. So time equals 4 hours a day. Then the man would like to know his weekly electricity bill if the cost of 1 unit is shilling. So unit cost equals to shilling 500, and they want us to find the weekly bill. So classic part A, help the man understand the meaning of 1. They want us to help this man to understand the meaning of 240 V, 60 watts. Then we have 240 V, 100 watts. We also have 240 volts, 120 watts. And then we have 240 volts, 200 watts. Well, then part B, determine the weekly electricity bill for the man. So we have this information summarized. This man has those electric appliances in his house: 4 inside bulbs, These bulbs, they are each rated 240 volts, 60 watts, and these bulbs are switched on for 8 hours a day. Two security bulbs, each rated 240 volts, 100 watts. The time for these security bulbs, they work 14 hours a day, and then a TV set rated 240 V, 120 watts that work for 10 hours. A speaker, a fridge rated as summarized above. The unit cost, the cost for 1 unit of electricity is 500 shillings, and then they want us in part A to tell the man the meaning of these labels on those electric appliances. To begin with, our task, this one, if the bulb is rated, the 4 inside bulbs, they are each rated 240 volts, 60 watts. The moment you see the rating of this bulb, it simply shows how much energy is consumed by that electrical appliance when connected to a main supply of a certain category. Now, the moment you see this, just know that that bulb that you have consumes 60 joules of energy per second when connected to 240 volt mains supply. That whenever you have 240 volt main supply, and then you have a bulb rated in this format, just know that it will consume 60 joules of energy per second or every second when it is connected to a main supply of 240 according to the Uganda electricity distribution for consumption. For domestic consumption, the distribution or power is distributed at 240 volts for domestic use. The bulbs may have different ratings depending on your choice. The security bulbs may not be rated the same like the energy savers. So the modules the bulb consumes, of course, the more light it gives, and then the lower the joules, the lower the joules that you saw in the bulb, so of course, the lower the light it produces. Then when you see this rating, the 240 V, 100 watts, which was labeled on, it was labeled, it's not indicated there, but they want us to give the meaning here. So it simply means that this electric appliance, if it's a bulb, then it consumes 100 joules of energy per second when connected to 240 volt supply. The same will apply to this 240 V, 120 watts, which is the labeling for the TV set. It simply means that that TV or that television set consumes 120 joules of energy per second when it's connected to a main supply of 240 volt. The same applies to the fridge. It consumes 200 joules of energy per second when it's connected to 240 volt main supply. Okay, let us go to part B. Part B, they want us to help the man determine the weekly expenditure, the weekly electricity bill. You see, it is always very, very good to know how much you are supposed to spend either in a week or a day to avoid that extravagancy. So in the process of budgeting, this man would love us to help him and come up with a weekly cost of electricity such that he can plan accordingly. Okay, now we shall put into account of what appliance uses what and for how long. Now, we know that for us to be able to determine how much this person is supposed to use in a week, we have to also know the total number of units of electricity this man uses. But again, total number of units, we realize from the theory that to get the number of units used or consumed, it is power times the time. But again, power must be in kilowatts. And we realize that all of these labelings here, we have power in watts. However, if it is in kilowatts, don't convert anything. But if it is given in watts, please convert watts to kilowatts. Because to get the total number of units, it is power in kilowatts, then times time in hours. cannot actually have it here. At B, we shall have units equals to power in kilowatts, then times time. This time must be in hours. So what if they give you time in minutes? You already know that 1 hour is equal to 60 minutes. So if it is 30 minutes, please divide 30 minutes by 60 and you have a half. Any minutes you'll be dividing it with 60 such that it is converted into hours. Okay, meanwhile, we are also required to change the power in watts, because this unit of power is watts. So we have to change it to kilowatts, because units is equal to power in kilowatts times time in hours. Okay, let's go slow but very sure. So let us begin with the 4 inside bulbs. So we are going to summarize each and everything. We are going to say inside bulbs to begin with. Now, inside bulbs, there are how many? They are 4. These 4, we can actually say, okay, there are 4 inside bulbs, but they are each consuming 60 watt or 60 joules of energy per second. Now, that means if I multiply this and that, it is 240. These are watts. But now we need power in kilowatts. Power in kilowatts. We know that 1000 watts is equal to 1 kilowatt. So we need to change 240 watts into kilowatts. We are just going to divide the 240 divided by 1000. So that and that will cancel, and then we have 0.24. These are kilowatts. Okay, now we can as well get the number of units consumed by these 4 inside bulbs a week. Now, this bulb is switched on for 8 hours a day, but they want us to find the weekly expenditure. That means we shall take into account of how many days are in a week. Me and you watching, we all know that a week has 7 days. That means I will now come here and say units consumed or units used by inside the bulbs now, inside the bulbs for a week. Now, since units is equal to power in kilowatts times hours, times time in hours, power in kilowatts is already here. So we shall simply say 0.24 times the time, but time must mean hours. Now, the time it works for 8 hours a day. So time was 8 for 1 day. But again, time was 7 days because we went for a week. Now, me and you, when you punch that figure 0.24, then time was 8 and time was 7, we're getting 13.44. These are 13.44 units. Now, these units are only for the 4 inside bulbs. We can now go to security bulbs. So, security bulbs. Now, these security bulbs, they are only 2. And so, we shall now have 2 security bulbs times 100 watts. Because each security bulb is rated that, and it consumes 100 joules of energy per second when connected to 240 volt main supply. So to get the total number of, or to get the total power consumed by the 2 bulbs, it is the 2 security bulbs times how much each bulb consumes. So we shall now have 200 watts. Then I come here and say power in kilowatts. So power in kilowatts will be equal to 200 divided by 1000. The 2 zeros will disappear, and then we have 0.2 kilowatts. Then units consumed, units used will now be equal to the 0.2, which is power in kilowatts, times time, and must be in hours. However, these 2 security bulbs, they each work for 14 hours, but again time was 7 days. So when we punch in our calculator, we have 0.2. Multiply this 0.2 times 14 times 7, we're going to get 19.6, and these are units consumed by the two security bulbs. Now, after finishing the security bulb, we are now going to the next appliance, and that is a TV. So now we are going to say TV, power consumed by a TV. So power used by TV set. Now it is only one and it is rated 120. So we shall have 120 divided by 1000 to convert it into kilowatts. And so when we divide that 120 divided by 1000, we are going to have 0.12, and this will be in kilowatts. Now, units consumed, units used by TV equals to power in kilowatts, which is 0.12 times time in hours. But this TV, it works for 10 hours a day. Okay, times 10. But we want how many units will be used in a week, which week has 7 days. So we now have 0.12 times 70. So between me and you, when you multiply 0.12 times 70, we are going to get 8.4. And this 8.4, these are units. Now, these units are only consumed by a TV. We still move to the next appliance, and that is a speaker. So we shall say speaker, and this speaker, it is rated 240 volts, 300 watts. That means it consumes 300 joules of energy per second when it's connected to 240 volt main supply. So we are going to say power in kilowatts. Power in kilowatts will be equal to 300 divided by 1000. This will give us 0.3. These are kilowatts. Then units will be equal to 0.3 times the time, but that time should be in hours. So it works for 20 hours a day. So 20 hours, but again times the 7 days. So if you have 0.3 times that, which is 140, it's going to give us, we have 0.3. So we have 0.3 times 140. Me and you, when we have 3 times 14, after a zero cancelling with the 3 over 10, we are going to have 42. These are units. Now, we are finalizing it with a fridge. So this fridge here, the fridge, power consumed by fridge, so we shall say power in kilowatts will be equal. The fridge, for it consumes 200 watts per second when it's joules of energy per second when it's connected to 240 volts supply. So it will be equal to 200 out of 1000, which is, because I'm dividing with 1000 simply because 1000 watts is equal to 1 kilowatt. And that simple algebra, hope will not confuse any of my followers. So when we reduce this and that, we shall have 0.2, and this is in kilowatts. Then units used, units will be equal to 0.2 times the time in hours. The fridge works for only 4 hours a day, and we have 7 days at hand. So this is 0.2 times 28. So if you have 0.2 times 28, we are going to have 0.2 times 28, we are going to have 5.6. So we are going to have 5.6. These are units. Now we have summarized. We've now seen the different consumption of the different appliances. We've seen that the two inside bulbs use or consume 13.44 units in a week. Security bulbs 19.6 units. A TV consumes 8.4 units. A speaker consumes 42 units. and then a fridge consumes 5.6 units. So let us now sum up the total units consumed by all the appliances all together. So total units consumed in a week by all the appliances. Total units used by all the appliances. So we shall have a summation of 13.44 plus 19.6 plus 8.4 plus 42 plus 5.6. So when we gently sum up that, have 5.6 plus 42 plus 8.4 plus 19.6 plus 13.44. We are going, we get 89.04. These are units. Now, these are the units consumed in a week. But remember, they have told us that the cost of a unit equals to shillings 500. So that is for 1 unit. How about the 89.04 units will now be equal to 89.04 multiplied by 500, and what we get here will be our money that this person is going to pay in a week. So we have 4,520, 44,520 Ugandan money, which is in shillings. So this person, this man here, according to the appliances that he has in his house, he is supposed to pay 44,520 shillings in a week. Thank you for watching. Subscribe for more videos.